Hello, welcome to section 4.5a, Homework Solutions. We're on page 296. I'm going to work 1 through 19 odd, and then number 27. This section introduces integration by substitution. A lot of people call it U substitution because that's the letter that's used. We could have used any letter, all right, but on 1, 3, and 5, all it asks you to do is pick a U and then determine the du. So U needs to be what you pick when you take the derivative of it. Du is sitting in the problem. It may be off by a constant, but it needs to be basically there. So for number 1, what makes sense to be U is 5x squared plus 1, right? This right here. Because if you take the derivative of 5x squared plus 1, then du is 10x dx, which is sitting right here. Okay, we didn't even have to adjust by a constant on that one. So it didn't ask you to rewrite this, but I'm going to go ahead and do that anyway in terms of U, just to kind of help you get, if you're struggling with this, then that'll help. If we rewrote this integral now in terms of U, it would be U squared du, because the 10x dx, that's du. 5x squared plus 1 is u. Okay? And then you had to square the u, and then we would integrate that, and that's very easy to integrate. It's 1/3 u to the third, and then you can substitute back in at the end. Okay, number 3, what makes sense to be u here is x squared plus 1. Because then du, if we take the derivative of u, it's 2x dx. All right? And then we can adjust the du because we need x times dx. So remember, the dx is out here, but it's really on top. It's multiplied by x, okay? So we can adjust and say 1/2 du, if we divide both sides by 2, is equal to x dx, and that's what we want. Okay, so that answers the question from the book. But now to rewrite this integral in terms of u, we would pull that 1/2 out front, and then x times dx is du, so that's on top, right? X times dx is just du. And then over the square root of u. And then you could integrate that easily. For number 5, the one that makes sense to pick u. Now, remember, tangent squared is the same as tangent x all squared. Okay? Those two are exactly the same thing. So if you pick tangent x to be u, the derivative of that has to be sitting in the problem. It could be off by a constant. In this case, it's not. So du, what's the derivative of tangent? It is secant squared, and then dx. And that's sitting right in the problem. So we would end up having u squared, because tangent is squared, u squared, when we rewrite this in terms of u squared, and then secant squared x dx is du. And that's easy to integrate. It's just 1/3 u cubed. Okay. So the answers that you would see in the back of the book would be these, but I took it a little further in case, because students oftentimes struggle with this at first and then suddenly it clicks. Okay, for number 7, we're actually integrating these, not just finding u and du. So u what makes most sense is 1 plus 2x. du, if you take the derivative of 1 plus 2x, the derivative of 1 is 0, the derivative of 2x is 2, then dx. And that's sitting in the problem. du is just sitting in there. We don't have to adjust at all. So we can rewrite this integral as u to the 4th, because remember, u just goes right there. That's u. U to the 4th, and 2 times dx is du. So we can integrate that. That would be 1/5 u to the 5th plus c. Now you can't stop there. You put u in the problem, you have to take u back out. So let's plug u back in. So that's going to be 1/5. U is 1 plus 2x to the 5th plus c. If you want to check that, take the derivative. 5 times 1/5 is 1 times 1 plus 2x to the 4th times 2. All right, and then you would get exactly this, back to your original equation. All right, moving right along. Number 9. So number 9 we have, now I'm going to rewrite this. It says the square root of 9 minus x squared. Let's rewrite it as 9 minus x squared to the 1/2 times negative 2x. So these first couple of them, they just put it on a silver platter for you. So we would want, let's let u be 9 minus x squared, because if you take the derivative of that, du is going to be minus 2x dx. So du is just this right here. It's just sitting in the problem, minus 2x dx. And so we can rewrite this in terms of u as u to the 1/2. Remember, u is right here. U to the 1/2 du. So that's going to be u to the 3/2, but I would need a 2/3 out front, because 3/2 times 2/3 is 1, and then subtract 1 from 3/2, you'd get a half, plus c. You put u in the problem, you got to take u back out. So that's 2/3. U is 9 minus x squared to the 3/2 plus c. All right, and you could check that by taking the derivative. You should do that on every test problem. Take the derivative so you can check and see if your answer's right. That'd be 3/2 times 2/3 is 1 times 9 minus x squared to the 1/2 times negative 2x. So I did that in my head, but write them out. Okay, number 11, we have x squared times x cubed minus 1 to the 4th dx. Okay, what here, if you take the derivative of it, it's sitting in the problem, but this time it is off by a constant, so we'll have to make an adjustment. U is x cubed minus 1. Take the derivative of that. Du would be 3x squared dx. Now I need it to be x squared dx. See, the dx is not right next to the x squared. That's okay, it's all multiplication. So it's sitting there, x squared dx. I need to divide both sides by 3. 1/3 du is x squared dx. Now we can rewrite this problem. Let's bring that 1/3 out in front of the integrand. And then we would have u to the 4th, right? U is x cubed plus 1 minus 1, but it's to the 4th power. and then du x squared dx. So that's du, and we took care of the 1/3. We could bring that constant out front. So when we take the antiderivative of that, I always just bring that 1/3 down. That's going to be 1/5 u to the 5th. You're taking the antiderivative of u to the 4th. I drop that down so I don't accidentally forget it. That's going to be 1/15 u to the 5th plus c. Now don't circle that. You can't leave it in terms of u. That's going to be 1/15. U is x cubed minus 1, so we're putting u back. We're taking u out. We're unsubstituting. Reversing the substitution. Plus c. Now I'm going to go ahead and check this by writing it out. Let's take the derivative of that. It's going to be 5 times 1 over 15. That's 1/3, 5 over 15. Times x cubed minus 1 to the 4th power times the derivative of this inner function. We called it the blob. So times 3x squared. The 3 and the 1/3 cancel, and you end up getting x squared times x cubed minus 1 to the 4th, which is exactly what we started with. All right. So this is, sorry about all that. We did the check. Let's make sure we circle the actual antiderivative there. All right, this is just the check. Okay, that was number 11. Let's look at 13. So now we're getting to where I think we're going to have to adjust some of these. We have 5x times 1 minus x squared to the 1/3 power dx. All right, so it's probably easier to rewrite this with that 5 out front. So I'm going to go ahead and do that. You can pull that constant out front. Now let's let u be 1 minus x squared. du is minus 2x, the derivative of this, dx. Now I need it to be just x dx. So if I divide both sides by -2, I'd have -1/2 du. That's, or you could say multiply both sides by -1/2 if you want. That's the same as dividing both sides by -2. It's equal to x dx, which is what we want du to be. So we can now rewrite this in terms of u. I've got a 5 out front, and I've got a -1/2 out front. We'll fix that in a minute. U is 1 minus x squared, so I'd have u to the 1/3 du. Okay, du is x dx, u to the 1/3. Okay, so I've got -5/2, and then I'm going to integrate this. It would be u to the add 1 4/3, but I'm going to need what out front? A 3/4. So I don't even think about this part. I'm just integrating u to the 1/3. That'd be 3/4 u to the 4/3. When I take the derivative of that, 4/3 times 3/4 is 1, then u to the 1/3 gives me that. Now I'm going to multiply that out. That'd be -15 over 8 u to the 4/3 plus c. Okay, don't circle that. All right, that's going to be -15 over 8. U is 1 minus x squared to the 4/3 power plus c. Okay, that's the answer. that's nasty enough that I'd like to check it. So let's take the derivative of that and make sure we're getting back to this. All right, 4/3 times negative 15 over 8 would be negative 60 over 24. Times 1 minus x squared to the 1/3 times negative 2x, the derivative of the inner function. So that's going to be negative, that's going to be positive 120 over 24, negative 2 times negative 60, 120 over 24 times 1 minus x squared to the 1/3 times x. Well, 120 over 24 is 5, and I can bring that x out front. And that matches what I had. Okay, so it worked. Again, you always want to check, especially on a test. If you check, I might be willing to give you a little more partial credit if you miss it. If you don't check, I might the red pen might be a little more reactive. All right, 17. We got 1 plus 1 over t cubed times 1 over t squared dt. Okay. That 1 over t, let's rewrite this. That's the same as 1 plus t to the minus 1 cubed times 1 over t squared. I could write that as t to the minus 2. All right, let's think about this. If we let u be 1 plus t to the minus 1, then du, the 1 goes away, right? It's minus t to the minus 2 dt. All right, that's the same as minus 1 over t squared dt. I need it to be just positive 1 over t squared. So if I multiply both sides by negative 1, I'd have negative du is equal to 1 over t squared dt. And that's what I need du to be. We just had to adjust by that negative out front. So I'd have a negative out front, in that right there. U cubed, remember u is 1 plus 1 over t, so that's right there, u cubed, times, you got the negative out front right there, times du. Because this part is du. So that's going to be negative out front, 1/4 u to the 4th power plus c. All right. Now let's plug that u back in. And we would have 1 plus 1 over t. It's to the 4th power, don't forget that. And then if we were to take the derivative of that, before that'd be 4 times the 4th, that'd be negative 1 times 1 plus 1 over t to the 3rd. And then times the derivative of 1 over t, which would give you negative 1 over t squared, and then those negatives would cancel, and you would come right back there. If you don't believe me, do it yourself by hand. You might want to rewrite that 1 over t as t to the minus 1. Give it a try, but I promise you it works. All right. So that one took up a lot of space, so I'll erase. Can do 19 and then 27. All right, 19, I've got 1 over. Now root 2x, I'm going to write this as 2x to the 1/2. So if we let u be 2x, then du is just 2 dx. I need it to be just 1 dx. So if we divide both sides by 2, I have half du is equal to dx. And I can rewrite this integral by putting the 1/2 out front, and I would have du on top, because the dx is really on top, over u to the 1/2 power. Remember, 2x is u to the 1/2 power. That's going to be the same as 1/2 u to the minus 1/2 du. Now we can integrate. Now I'm just going to drop down that 1/2 so I don't forget it. I'm integrating u to the minus 1/2. Add 1, and I'd have positive 1/2. All right, but I would need a 2 out front. 1/2 times 2 is 1, then u to the minus 1/2. So that 1/2 and that 2 cancels, and you're just going to get u to the 1/2 plus c. So let's plug the u back in. That's 2x. And I'm going to write it like that, root 2x plus c. Okay, you can check that by taking the derivative of 2x to the 1/2. So that'd be 1/2 times 2x to the minus 1/2 times 2, the derivative of the inner function. 2 times 1/2 is 1. So that equals 2x to the minus 1/2, which is the same as 1 over root 2x, which is what we started with. So the check worked. All right, nice. Hopefully you're starting to get it, but there will be plenty of these to practice with on the test review. All right, 27, last one. So I went pretty slow on these. In fact, I'm going to write it the way they did. They want you to solve the differential equation. You have dy dx is equal to 4x. So we're going to end up integrating. Plus, remember, this is the integration chapter or antiderivative chapter. So when in doubt, take an antiderivative. Okay. So if solving the differential equation just means I need to get an equation of y equals something. So first of all, let's separate the variables by multiplying both sides by dx. And then that's all going to be multiplied by dx. See, that's the same thing. We just separated the variables. Now we're going to integrate both sides. So the antiderivative of dy is just y. So all this was seeing if you understand to solve the differential equation, you have to integrate. Okay, so we're going to integrate 4x. That's 2x squared. But I'm going to have to use a substitution for this second part. And that's where most of the work comes in. Okay, so this is the part we're going to work on. That part was easy. Okay, let's let u be 16 minus x squared. And then du would be minus 2x dx. But I need it to be 4x dx, don't I? So how about we multiply both sides by negative 2? So negative 2 du would be 4x dx. So now I can rewrite that integrand. I got a negative 2 out front. 4x dx is just du. So we have du on top over the square root of u. Okay, u is 16 minus x squared. It's a square root, so we've got that. 4x dx, that's du. And then I had to put a -2 out front to adjust it, which we did right here, to make it 4x dx. That's the same as -2 times u to the -1/2 du. So not u to the 1/2, u to the -1/2, because we brought it up top. So that's -2, got to be careful with that, u to the 1/2, but I need a 2 out front. 1/2 times 2 is 1, then subtract 1. So that's going to be -4 square root of u plus c. So putting the u back in terms of x, -4 times the square root of 16 minus x squared plus c. Okay, so now we're going to write all this out. Y is equal to 2x squared. That was the easy part, right? And then integrating this whole second part is going to be -4 times the square root of 16 minus x squared. And don't forget the plus c. So it's pretty easy to check. You can go ahead and check it if you need to. All right, and I'm going to let you do that. If I remember if you were checking it, you might rewrite this as 16 minus x squared to the 1/2, and then you'd use the chain rule, but you would end up getting back to this if you did that. Okay, that does it for this video. I hope that cleared some things up if you were having trouble. Remember, just keep practicing. If you struggle with this, maybe you go rework them all. Give it another day to kind of leak out of your brain, and then we rework them all. And you're going to have a lot of these to try on the test review. So most students get U substitution by the time of the test. They usually do really, really well on that part. So just takes a little bit to train your brain to look for these substitutions. That's what math is about in a lot of ways. It's a lot about substitutions in order to make things easier to solve. All right, talk to you next video.